Okay, this is your 10.1 to 10.3 double six-fer. So there are 6 questions. Each one has 2 parts, and it has to do with reviewing for your test, which probably should be the end of the week. Here we go. So question 1 says, what is the constant and coefficient in these 2 equations? So your constant, if you want to know what the constant is, it's the part of the equation that is added or subtracted from the variable amount. So sometimes if you have something like 2x and you have equals 5, but x is equal to 2, these aren't equal. So you put a constant in, like a plus or minus value, that allows those 2 sides to be equal. So technically a constant is just a part of an expression that does not contain the variable. So in this particular one, that is our constant. So we would say positive 4. So we would say the constant in this one is positive 4. Even though the positive symbol is not there, it's 4. And sometimes it's best to see it if we were to draw it. We'd have 4 positives and 2 negative x's, and then we'd have equal 3. Which brings me to the next part when I say, what is the coefficient? And a coefficient's job is basically to tell you how many of the variable you have. And in this case, we have negative 2x. So negative 2 of them, which means I would subtract 2 times the value. So our coefficient for this one is negative 2. Okay? Not positive 2, not plus 2x, but minus 2. In the second one, our constant is that part of our expression that has the variable in it. So there's the expression with the variable in it. And it's that part that does not have a variable. So in this case, it's minus 1. So our constant for that one is minus 1. And our coefficient is a little tricky. So if I ask how much of x do you really have there, you do not have 3 of them. And if I was to draw it, I'm going to ignore the negative because that's hard to draw. But this would be a third of x. Or, if I wanted to think of it a different way, a third of x. Or, since 1/3 is 0.3 repeating, it's a coefficient of 0.3 repeating. Okay? So the coefficient in this particular expression would be negative a third or negative 0.3 repeating. Both coefficients would be correct. In the second question of our 6-fer, it says write the equation and solve. So it says a fifth of what number is negative 2? So a fifth of a number would be written as x divided by 5. That would be representing a fifth of whatever number you want to look at. So if x was 10, a fifth of that number would be 2. If x was 50, then a fifth of 50 would be 10. Equals, so our is sign is really like the equal sign, negative 2. So our equation for a fifth of what number is negative 2 is that. I know that x by inspection has to be 10 because 10 divided by 5 is 2. And therefore I know that through inspection, x is negative 10. If I solved by opposite operation, I would multiply both sides by 5, and I get x equals negative 10 as well. In the second example, it says negative 4 is equal to, so negative 4 is equal to the sum, which is addition, of 4, a sum of 4 and 2x. So there's our equation. Negative 4 equals 4 plus 2x. My constant is 4 because it's on the side of the variable that's not attached, in this case 4. So I'd subtract 4 from both sides. I get negative 8 equals 2x. I would divide both sides by 2. And I get x equals negative 4. Okay? So negative 4 is equal to the sum of 4 and 8. Negative 8, excuse me. That's true. The third one is write the equation and solve. Oh, I just did that one. That's not what it is. Is this the third one or the fourth one? That's the third one? Is it? That's the fourth one. So I must not have, hang on. Okay, there, that's fixed. So these 2 questions asked to solve with modeling. The third question. So the first thing I'm going to do is draw 4 integer chips, 4 positive integer chips, which represents the constant, plus 2x, these are positive x's, so I'm going to do plus 2x, equals 2 negative integer chips, or negative 2. So the first thing I'm going to do, I know that in algebra, whatever I do to one side, you can do the other. So in a grade 8 level, I want to get rid of my constant by applying negative 4 to both sides. That creates 0 pairs, and what I'd be left with on this equation is 2x's equals negative 6. And if I was to isolate the variable from that, if 2x's have a value of negative 6, then each x must be worth negative 3. The second question says negative 1 equals negative 1 plus positive 4. So if I draw it, I have negative 1 equals negative 1 plus a quarter of x, or x divided by 4. Now, common sense says that this particular part right here, if I was to erase that, would those two sides be equal? Yes, they would. So by bringing that back, I realize that whatever that is, it can't have any weight. So just by modeling, I know that a quarter of x has to be nothing, which means x has to have a value of 0. But I'll go through the motions of isolating. So I'm going to add 1 to both sides. I create 0 there. And over here I'd have nothing has a weight of a quarter of x. Now if I wanted to, I could quadruple both sides. If I want to go through the motions of figuring out what it is. And if I quadruple the left, I still have nothing. So therefore x would equal nothing. And therefore x is 0. In the next question, solve with inspection. I have to write a question, so I'm going to write it down with a Q, I think. Question. What number, when I'm talking about my variable, it's what number divided by negative 4 is positive 4? Okay, so what number divided by 4 is 4? Well, I know that is 16. 16 divided by 4 is 4. And is it going to be positive or negative? I know it has to be negative because a negative divided by a negative gave me this positive. So the answer is negative 16. And the second question is negative 5 multiplied by I should do that differently. I should say a number multiplied by negative 5 is negative 10. Or what number? Actually, it should be what number? What number? What number multiplied by negative 5 is negative 10? And the answer, well, 5 times 2 is 10, and a negative times a positive is a negative, so my answer would be positive 2 for that one. That's the reasoning you need to go through with solving by inspection. And question 5 says use opposite operation. These are one-step algebraic equations because I just have a coefficient. Again, if I was to rewrite this question, I could think of it as being negative 0.5, negative a half x equals 5, or negative half of x equals 5. Both of those are appropriate interpretations of what that says. But if I'm using opposite operation, I'm going to divide both sides by negative 2. Times both sides by negative 2. And x will equal the product of 5 and negative 2, which is negative 10. Now on your test, if you were to have that question and you solved it with negative 10, what you should do next is take your x value, substitute it for what you found, in this case negative 10, and see if those two sides are equal. In this case, negative 10 divided by negative 2 is 5, so that is the appropriate value. And using opposite operation here, I would divide both sides by 3, and I get x equals negative 3. Check your answer by substitution. So negative 3 times x, or negative 3x equals negative 9 is true because negative 9 does equal negative 9. And our last set of questions, we have two-step equations that we have to solve with opposite operation. In the first question, I have to identify what my constant is. In this case, it's over here with the variable. It's minus 7. In order to get rid of a minus 7, I will add 7 to both sides. I'll have negative 2x left on the right-hand side and 11 over there on the left. My coefficient is negative 2, so I will divide both sides by negative 2. And x will equal half of 11, which is 5.5. A positive divided by negative is a negative. Substitute into my equation again what I solved it for. Negative 2 times x, same thing as negative 2 times negative 5.5. Minus 7. 4 equals 11, because a negative times a negative is a positive. And that is true. 4 does equal 4, so x's value is negative 5.5. And the last question, our constant is 5, so I'm going to subtract 5 from both sides. Now here's where it gets tricky. What's left is this expression. Take away half x. And when you're given that option, there's two ways you can interpret it. Three ways, actually. All three of these, this, and this, are all expressing negative half x. Okay? So when given this type of problem, when you rewrite your next step of your order of operations, it's always best to keep your negative sign in your denominator. Because when you do so, it allows you to multiply both sides by negative 2 to finalize or to isolate your value of x. Since I multiplied that side by negative 2, I'll multiply this side by negative 2 and I get x equals 12. Go back into your original equation. Substitute 12 for your x and solve it. And it does work, so x's value is positive 12.